All right, so tonight we're going to talk about some properties of numbers. But before we get into that, how many times have you ever gotten a problem that looks something like this? 4 plus 8 plus 6. And instead of going for what's 4 plus 8 and then plus 6, you added 4 plus 6 first and then added 8. Well, if you've done that, then you've been using the properties of numbers all along without even knowing it. Because we use the properties to make concepts in math easier for us to use. Today's topic is the properties of numbers. So let's start with the first property. And the first property is the commutative property. The commutative property, there are two different commutative properties. The first of the commutative properties, and I'm going to abbreviate these, so I'll teach you the abbreviations, but the commutative property of addition. The commutative property of addition says A plus B equals B plus A. It basically says it doesn't matter which way you add, you're always going to come up with the same number. I always think of commutative like commuting, like I'm going there and back, and it doesn't matter if I'm going from home to school or school to home, or vice versa, it's still the same thing, it's still the same distance. The other one is the commutative property of multiplication. And that's the one that says A times B equals B times A. Nothing spectacular, that's just what it is. The next property is the associative property. And on this one, when I hear associative, I think of association, or people I associate with, like my circle of friends. And it doesn't matter who I say hi to first, as long as I say hi to all of them. And that's kind of what the associative property says. So the associative property of addition says, I don't care if you do A plus B and then C, or if you do B plus C first, because that's in parentheses, and then add A. So that's the associative property of addition. The associative property of multiplication is just the same, except in this case, it talks about how the order we multiply in really doesn't make a big difference. The next property we're going to look at is the identity property. Now, when you hear identity, I kind of think about my identity, and that's who I am. And no one's going to change who I am. And that's part of what this is all about. It's not changing the value of a number. The identity property of addition says I can take a number, I can add something to it, and I could get A back. Do you know what you can add to a number and still get that number back? Yep, that's right. You can add 0 to it. And 0, by the way, this is known as the additive identity. The identity property of multiplication says I can take a number, multiply it by some number, and get that number back. What number can I multiply by any number and get that any number back? Yep, that's right. it is 1. And 1 is known as the multiplicative. Yes, say that with me. Multiplicative. It's a funny word. Multiplicative. And it's the multiplicative identity. One that's not in your book, but we're going to talk about it anyways, and we will get to this later on, is known as the inverse property. The inverse property of addition says if I have a number and I add the opposite, those are known as additive inverses, I get 0. The inverse property of multiplication says if I take a number and I multiply it by the multiplicative inverse, I end up with 1. So that's kind of just another property I thought I'd throw out there to you, known as the inverse property. Another property that is in our book is called, okay, it's not going to erase, so I need to erase it. Is called the multiplicative, there's that word again, property of 0. The multiplicative property of 0. And this one of my favorite properties, says if I take any number and multiply it by 0, I get 0. So yes, so a times 0 does equal 0. Now, one thing that you're going to come across that we need to talk about is called a counter example. A counterexample is used to show why something doesn't work. Like, for example, is division commutative? And we can show it's not by using a counterexample by simply saying that 4 divided by 2 does not equal 2 divided by 4. One of them gives us 2, the other one gives us 1/2, and obviously those are not equal, so we can show by that that it is not, that with the counterexample, that it's not true. Now, here's a question for you, and I want you to think of this in just general terms for a second. If I have an apple, actually, no, don't laugh at my apples. If I have 3 apples, and my friend gives me 4 more apples. That's a sad-looking apple. These are all sad-looking apples. Sorry, you'll learn I cannot draw. And my friend gives me 4 more apples. How many total apples do I have? Yeah, correct. I have 7 apples. If I have 3 apples, and my friend gives me 4 cherries, what do I have? No, I do not have a fruit salad. What I have is 3 apples and 4 cherries. Now, you've got to be wondering why I'm here talking about fruit. Well, the reason is variables work the same way. The number in front of the variable is what we call a coefficient, but it tells us how many of that variable we have. So if I said, if you have 5x plus 7x, then I would add all those together. I have 5x's, I have 7x's. It gives me 12x's. If I have 6y's and 8y's, what do I have? Yeah, I have 14y's. But what is 3x plus 4y? No, it is not 7xy. Try again. Ah, stumped you. Well, think of it as apples and cherries. You actually have 3x plus 4y. You cannot combine those together. If I have 4 plus 8y, what do you think 4 plus 8y is? Good. That is 4 plus 8y. They're not what we call like terms. Now, we'll talk more about like terms later on, but I wanted you to see that because part of what we're going to do today is about simplifying. Simplify. To simplify something means that we're going to perform all the operations we can to combine all the like type terms together. So, for example, if I have 3 plus e plus 7, well, I know those parentheses are there, but you know what? I could use, for example, to make this easier, I could, inside the parentheses, use the commutative property. So that was the commutative property of addition to make that, to change the e and the 3 around. Why'd I do that? Because then what I could do is change the parentheses by using the associative property of addition. And then I know 3 plus 7 is 10, so I get e plus 10, and that's because I just simplify. This actually is what's called a proof and deductive reasoning. And it's something that we are going to work on a little bit in the next couple of days, is how do you prove things, some problem-solving strategies for that, but mostly on simplifying expressions. All right, so what I want you to do is I am going to give you a few problems to do here that you are going to come in with tomorrow with the answers. So for the first thing, name the identity. Name the identity. And then I want you to simplify. All right, try those, and I will see you tomorrow.